Good morning, good afternoon, good evening, depending on where you have joined from. Welcome everyone to yet another webinar from SQL Maestros. My name is Amit Bansal and I'm going to be your host, your speaker for the next 45 to 60 minutes. Welcome once again. This webinar is in a series of webinars that we are doing on SQL Server indexes. Last week, we delivered the power of indexes. And to answer your question, which you have not asked, but you will ask shortly, was that webinar recorded? The answer is yes. All our webinars are recorded, including the last one, the previous one that we had delivered. It's available on sqlmaestros.com. So the link is right there in the chat window. Feel free to access a lot of content out there, masterclasses, video courses, recorded webinars, the free video lobby, the premium video lobby, free membership, premium membership. All of you are invited. A lot of free content. But of course, to keep our shop running, we have to have some paid content as well. All right, friends. So thankfully, we are able to do today's webinar as well. There were a few hiccups in a month back where some webinars got postponed. But then I'm glad we have been able to do the last week and this one. So if you are someone who is working on SQL Server and you have been working on SQL Server for some time, or you are new to SQL Server, sooner or later you will have to deal with indexes, especially if you're a lot involved in performance tuning or even in database design architecture. As a developer, you will have to come across indexes. Before we start off with the content, few housekeeping questions. So the housekeeping caveats. So the first, about recorded webinars, I already answered that. All our webinars are recorded. They're available on sqlmaestros.com. Many of them are free, some of them are paid. I would strongly recommend that don't subscribe to paid webinars individually. It's always good if you take up the paid, or whatever we call this as, premium membership on sqlmaestros.com, which will give you access to all our recorded webinars one shot. So, and it's an annual subscription. So don't need to go in for individual stuff. The second thing is questions during the webinar. Please use the Q&A panel to ask questions. Avoid using the chat window. As we move forward with the content, when we are done with a specific demo or a content piece, I will go to the Q&A window section and look for your questions, and I will answer them on the go. And of course, at the end of the webinar as well. If we hit on the top of the hour and there are a few questions left unanswered, I will share a LinkedIn URL with you. Each week when we do a webinar, I post a message on LinkedIn, and I will share that URL with you. So you can actually post your question back there on that link as well. And I will answer that maybe tomorrow then on that one. Okay, so with this, these are the 2 or 3 important things that these questions keep coming. And so yeah, let's begin with indexing architecture part 1. So just a quick recap of what we did last week. Last week's webinar was about the power of indexes. And the whole idea was to give you a summary, which is, in my consulting engagements as a performance tuner, about 70 to 75% of performance issues, query tuning issues, they get resolved by having the right indexes in place. So believe it or not, but indexes play such a critical role. And in last week's webinar, I showed a couple of real world examples where indexes help so much in tuning query performance. So if you have not watched last week's webinar, you could watch that. That's more like a trailer. And now today's webinar and the next one, which is indexing architecture part 1 and part 2, we are going a little deep into understanding what is the index architecture all about. Today's webinar will be like level 100 stuff, where we are going to discuss very basics and the overview. And part 2 will be a little more deeper, like level 200, 300 stuff. Then we have another one. So we have a couple of webinars coming up on indexing, and I'm just going to show that to you on the screen now. So yes, all of you, welcome once again. Friends, just to let you know, we have hit 200 people in today's webinar, which is really good to see. And I know which makes me very confident about this topic. This topic is like evergreen, very popular. We generally have about 150 plus, but today we hit 200 in attendance. So yeah, thank you so much. And I hope the content is worth your time. Let's move forward. What's lined up in the coming weeks? Last week we did the power of indexes. Today we are doing this one, SQL Server Indexing Architecture Part 1. The week after next, we are doing SQL Server Indexing Architecture Part 2. And then end of the month, 28 March, we are delivering index tuning, clustering key choices. And then we have a index tuning masterclass. If you really love the content and these webinars and you think, yeah, you are someone and it will really help you to dive deeper into index tuning, like you need masterclass level 400 kind of content and all of it about indexes, then you might consider joining the index tuning masterclass live. So this will be like a 15-hour program, 3 hours each day, Monday to Friday. So the whole week, but just 3 hours each day. So you could balance between your job and learning. And you get access to the recordings for a lifetime. It's very important that you know that all our content access is for lifetime. So whether you take up this masterclass or you take up the previous masterclass recordings, which we did in December, that was on SQL Server Performance Tuning 40 hours. We do get a lot of subscriptions each week. So if you subscribe to 40 hours performance tuning masterclass recordings, you get lifetime access. Watch anytime, anywhere, as many times as you want. Okay, so that's the summary of what we have for you in the coming weeks. Now, let's begin. First key point about indexes. Both can affect database performance, lack of right indexes and poorly designed indexes. So not having the right indexes, of course, you can understand, will affect query performance. The whole idea, the whole objective of this entire discussion is to have the right indexing strategies. But then in most cases, in many cases, we see that there are indexes, but they're not designed properly. Now, you might wonder, what do I mean by really not designed properly? So they're poorly designed. The choices of columns, in most cases, I see the choices of columns are not correct, or the order of columns in a multi-column index is not correct. So real world, and all of you will resonate with me on this thought. Seldom will you really go and create single column indexes. In many cases, we go and create multi-column indexes. And there is a lot of confusion and things get complicated when you have to deal with multi-column indexes. What should be the order of columns? When you design an index, column A, comma, column B is not the same as column B, comma, column A. And with the introduction of that include keyword, things get even further complicated. When do you put an attribute in the index definition, which is part of the index key? And when do you take an attribute off from the index key and include it in the include keyword? Those are the common mistakes that lead to a poorly designed indexes. So keep these two things in mind. Next, the selection of right indexes for a database and its workload is a complex balancing act between query speed and update cost. Wow, overloaded statement. I took this up from my Microsoft documentation because I love the statement. It's a complex work because when you add more and more indexes, you are focused so much on improving the query performance of your select statements, you tend to ignore that your DML queries are now suffering, which is insert statements, update statements, delete statements, and things like merge statements. All of them are making changes to the data. So the more indexes you add, you remember each of these updates have to, go and update one or more indexes. So there's more and more and more work to do. So you got to balance. Just because you can create a lot of indexes on a table doesn't mean that you will go and create so many indexes. You have to perform a balancing act. The focus of our learning and focus in generally is on OLTP environments. This training that I'm doing, this content, these demos, these discussions are kind of tuned and focused towards OLTP, not OLAP, not decision-making systems, etc. So selection of right indexes, complex activity to balance between select queries and DML queries. feel free to experiment. The best thing that has worked for me over the years is experimenting with different options to see what works and what doesn't work. And experimentation really here means that you try a lot of different options and then you record performance metrics, which I kind of generally term as baselining and benchmarking. Also note that SQL Optimizer does a good job. Always, almost always. What I mean by this is rarely, very rarely will you see that, okay, you have good indexes in place, but probably they're not being used by the optimizer, or you have like two indexes, one of them is the right choice, but for some reason optimizer takes up the second one, so on and so forth. It's very difficult to reproduce or kind of create such bad scenarios where the optimizer goes wrong. So, I mean, I have come across customers and DBAs on customer sites who would blame the SQL optimizer for not doing the right thing and kind of terming the optimizer as buggy. And that's why I put up this point, which is the optimizer will do a good job almost always. So let's get this out of the discussion, because in most cases you're always, those are edge cases really, where very rarely will you see optimizer going wrong. Okay, let's move forward. Now, what are the different types of indexes that you have at your disposal? Row store. This discussion of row store comes in only because now we have something called as column store indexes as well. But a few years ago, there was like no discussion of row store versus column store or something. You just like had clustered and non-clustered. Okay, but now we have this classification. So in row store, you have clustered indexes, non-clustered indexes, unique indexes, and filtered indexes. So that is all part of row store. Then you have another classification of column store indexes now with clustered and non-clustered column store indexes. Then you have memory optimized indexes, the hash indexes, and the memory optimized non-clustered indexes. This is to do with the in-memory OLTP world. That's a different engine altogether. And then you have special indexes like XML, spatial, full text for very specific scenarios. So our focus for all these webinars and even for the masterclass content is going to be on the first one, which is row store, clustered, non-clustered, etc., etc. Now, let's jump over to the index design basics. This is something that you have come across so many times when you have been learning about SQL Server and indexes, but I thought doesn't matter. This has to be the right way to start off an indexing discussion. So I bring this slide up. Sorry if you have seen this so many times, but yeah, a good reminder and refresher for many of you. On the left side, what you see is the table of contents, and on the right side, you see the index. And what you see on the screen in totality looks like something like a book. The table of content is one of those first few pages that you see in a book where everything is kind of sorted in terms of like chapters. So you have like chapter 1, 2, 3, 4 nicely sorted on a specific key. Here you have the name of the chapter or chapter itself. And then you have the page numbers. And if you see, these page numbers are kind of sorted starting from 1 and they go all the way higher up. This is what is kind of a good, representation of what could be a clustered index. And now again, for many of you who are new to indexes and SQL Server, you would be like, okay, what is a clustered index? We'll come to that. It's like chicken and egg thing. Now, do I discuss the analogy here first, or do I directly jump into technical aspects? So we'll do that. You will be able to connect the dots as we move forward with the slides. So what you have on the left side is like a clustered index, which is the data itself, something like, okay, I want to go to chapter 5. So chapter 5 here is the page number, and then I directly jump over to the page number. On the right-hand side, you have something what we call as the non-clustered index. Now, when you read a book, of course, there are a lot of keywords in the book. And, sometimes publishers and authors and the reviewers, they decide on a lot of different keywords they think the user might want to search on. So what we have at the back of the book are a few index pages. Those are additional pages, mind you, right? Those are additional pages where you have some keywords, and those keywords are also alphabetically sorted, ascending, of course, in most cases. Um, and you will see, as per the diagram, you have A, B, C, D, and you have those keywords alphabetically sorted. And then next to the keyword, you have the page number. Again, the idea is, as a book reader, you might have different keywords in mind while you're reading the book, and then you may want to search on certain keywords. So we kind of assume that, okay, this keyword is important. So as a reader, you go to the back of the book with those and look for that keyword in the index pages. And if you're lucky, if you know, if your thought process is matching with the authors and the publishers, probably you will find your keyword in those in those index pages, and then you have a pointer to the page number. So you have your keyword, you have the page number, you just directly go to the, you kind of flip pages and locate that page number, and then you find your content. So what you see on the right hand side is a representation of a non-clustered index. Based on, these are kind of good analogies of how indexes are represented inside a database also. It will not match exactly like what we see here, but the concept is same. I know in a lot of books we use telephone directories and whatnot. Well, they're all good. They're all good analogies to kind of compare. So let's begin with clustered index first. Now, when you create a table for the first time, let's say you have a database and you just create a table with the create table statement, create table something, and you put a few records. That table technically is called as a heap. Okay. I will come to the heap in a moment, but I straight away wanted to jump into clustered index. So that is called as a heap. Do I have a, okay, let's do this. Let's flip the slides a bit. So what you have right now is a heap in front of you, right? Because you created a table and that table has no indexes. What do you have in a heap? Technically, this is called as a heap. Bunch of data pages. Each data page in SQL Server is like 8 kilobytes, and you have bunch of these pages in no specific order. So they're unordered, lying on the disk. So you could see bunch of pages out there here, like you have 8 pages here, 8 pages here, and 8 pages. Why did we group 8 pages together? Because inside SQL Server, 8 pages make an extent. Now, I don't want to get into the storage architecture because then we will deviate our discussion. Let's stick to indexes. So we have this heap. Heap has nothing to do with indexes because we haven't created a clustered index. We haven't created a non-clustered index. Think about this book. Think about this book without a table of content and without index pages at the back of the book, just a bunch of pages. Now, what you also see in this diagram is on the left hand, on the top left, you have index allocation, map pages, etc. I will ignore all of that. I will skip that for the time being because, as I said, that will take us into a lot of technical architecture about the storage, which is not required at this moment. But I'll just briefly cover what you see on each page. So here is a kind of a zoom in on a specific page, and you can see this page has all the attributes from a table, which is like order ID, customer ID, employee ID, etc., etc. So that's a heap. Now, what do you do? Generally, in most cases, what you will do is on a heap, you will go ahead and create a clustered index. So when you create a clustered index on a heap, it will order the pages based on the clustering key. So let's say you have created a clustered index on order date. Now all the pages, let's assume that this is an orders table and you have created a clustered index on order date. Now all the data pages in this table will be arranged, will be sorted on order date. And by default, it is going to be ascending, right? Now, because there's only one way how the pages can be sorted physically, that's why you can only have one clustered index on the table. Now, the moment we make the statement, a table with a clustered index, we sometimes kind of think of this as two different objects. So you have a table and then you have a clustered index on the table. So this looks like two different storage objects. No, The moment you create a clustered index on the heap is converted to a clustered index. So earlier, the table was a heap. Now the table becomes a clustered index, which means clustered index is the data. I repeat this, and I repeat this only for newcomers, the new people in SQL Server world. Clustered index is the data. It's a single object, it's a single storage unit, and these are not multiple objects. Earlier, the table was a heap because there was no specific order of the pages, but now you added a clustered index, and you chose a clustering key to order the pages on that clustering key. Now those pages get ordered. SQL Server will take some time to create the clustered index, and what you see on the screen is a B tree structure uh, of the clustered index. So clustered index is the data. Now, those index allocation map pages, etc., will all be there. And then you can also see the data page again, order date, order ID, customer ID, etc., etc. And there are more columns out there. But the most important thing to note here now is what has happened is when it was a heap, it was like bunch of pages lying in a unordered fashion. The moment you create a clustered index, a B tree structure gets created with a root page, which you see right on the top. Then you have in an intermediate level, so like bunch of intermediate level with some pages, and then you have the leaf level, the bottommost level. The bottommost level are the leaf level. The bottommost level is called as the leaf level, and this is where your data pages, your actual data page is. What you get at the root level and at the intermediate level are additional pages, and these pages are called as index pages. And now all of you are probably guessing what's the purpose of this. The purpose of B tree structure here and the whole structure of root and intermediate and the leaf level is for the optimizer or for the storage engine to traverse the B tree structure to find the data that you are looking for, which is start the navigation from the root page, jump over to the intermediate level, and then from intermediate level to the leaf level. This is what we call as seeking the data. When we had a heap and we were searching for the data, we will scan all the pages, we will scan all the data. But the moment indexes come into the picture, in most likelihood, we are going to seek upon the data. Seeking here means traversing the B tree structure of the index. Now, we will look into a lot of different examples the moment we start jumping into demos, but I hope the concepts are getting clear. The moment we talk about indexes, we are talking about the B tree structure. The moment we are talking about the B tree structure, we are talking about this root, intermediate level, and leaf level. Okay, let's move forward. Non-clustered indexes. Non-clustered indexes, friends, are no different in terms of technicalities, in terms of architecture, in terms of design, in terms of the schema. It's the same concept. You have a root page, you may have one or more intermediate levels, and then you have the leaf level. Exactly everything is same. The only difference here with the non-clustered indexes, while clustered index is the data, and you can have only one clustered index because there's only one way how you can sort the data. So you have the clustered index, but you can have bunch of non-clustered indexes. You can have more than one non-clustered indexes. So non-clustered indexes, remember, like for example, in a book, the table of content, you would only expect one set of table of content, right? Like chapter 1 to chapter 20, ordered in a specific fashion. But at the end of the book, you can like have many keywords, and can have different types of indexes to point to the data back into the book. Likewise, you can have multiple non-clustered indexes. You can have a non-clustered index on last name. You can have non-clustered index on first name. You can have non-clustered index on phone number, on address, on any attribute that you think is important, which also means that each non-clustered index is a separate storage structure. Yes, the more non-clustered indexes you create, you're asking for more storage from SQL Server. And of course, these objects are separate objects, and they have to be maintained, they have to be stored. and they have to be updated also. And this is where that discussion comes in, like striking a right balance between the performance of your select queries and your DML queries. Okay, so we looked into just very quickly heap, clustered, and non-clustered indexes. Now, just to summarize, what are the different options that you can have, in front of you? You can have heap with non-clustered indexes. So heap here is a table on the left side, bunch of pages in no specific order, and then you have created multiple non-clustered indexes, which you see on the right side. Yes, this is possible. It's not a very common scenario to deal with. It's not very, you won't really come across a lot of different designs where you actually have a heap, a table without a clustered index, but bunch of non-clustered index, but that is technically possible. But most likely, you generally will see a table with a clustered index, which is a clustered table, informal term, clustered table, which you see on the left side, and then you will have bunch of non-clustered indexes on the right side. So the clustered index is also a B-tree structure, and bunch of non-clustered indexes are also B-tree structure. You can have more options. You can just have a heap without any index. That's possible. You can just have a table with a clustered index, but no non-clustered indexes. That is also possible. Okay. Let me ask you a question. Typically, you would ask me a question. I'll ask you a question now and put your answers in the chat window. Okay, friends. When do you think it's a good scenario to have a table with just a clustered index, but no non-clustered indexes at all? But you just have a table with a clustered index. That's all, a clustered table. But you never felt in need of putting a non-clustered index on that table. Do you think, can you come across any scenario like that? Have you ever dealt with a table or bunch of tables who would like, this doesn't need a non-clustered index. I'm just good with a clustered index on this table. Okay. Answer, Mark says simple lookup tables. When your application has search on only primary key, typically an index with would not be changed. Table with few columns, dimension tables, large lookup. Okay. Well, some of you are giving good answers. Yes, because when you say lookup tables, master data, etc. Well, the answer here is whatever the scenario is. I'm sure you are coming up with answers based on your projects. Small tables. Yeah, the answer is small table. Whatever the purpose of that small table, it could be a small dimension table, it could just be a small master table, it could just be a small lookup table. But the common characteristic of that table is that it's a small table, maybe just a few thousand pages or less than 1,000 page or so. Optimizer would not really bother about using indexes for such small tables. So they really do not benefit at all, or even if they benefit, would be just very, very negligible, very, very negligible, very minuscule and tiny. So those are tables that may not benefit with non-clustered indexes. If you want to watch the remainder part of the webinar and all the remaining demos, you can subscribe to the webinar on SQLmaestros.com and get lifetime access to the recorded webinar. All you have to do is just go to SQLmaestros.com, click on the recorded webinar section and get access to all the webinar recordings. There are many of them. Some of these webinars are free and some of them are very nominally priced. So the ones that you're interested in, you can subscribe to them and get lifetime access. Now, because there are so many webinars, subscribing to each webinar might be a bit cumbersome. So we have another option, which is SQL Maestros membership. So the first link on SQL Maestros says join. If you click on that, it will bring you to SQL Maestros membership. Things are very simple. There are two membership levels. The first level is free, where you get access to all the free webinars and all our tutorials and demos, more than 200, 300 demos and tutorials. All you have to do is just become a free member. You're paying nothing and you get access to all of them. So you don't have to go and subscribe to each webinar individually. Just become a free member and then explore the free video lobby. So if you go to the video lobby here, there is something called as free content, where you get access to all of that. But then all of us are interested in advanced content, isn't it? And that is where premium membership comes into play. So the webinars that are paid, and there are many advanced tutorials and demos. If you want access to all of them, you can become a premium member and pay a nominal price, which is annual membership. Once you do that, you can explore the premium video lobby. If you go to the premium video lobby from here, or just go to the video lobby and click on premium content, you can see all the paid webinars and all the advanced tutorials and demos, and get access to all of them with your annual membership. Anyway, choice is yours. There's a lot of content on SQLmaestros.com, and you can also explore the YouTube membership level as well. So you have free content on YouTube channel, and you can also join and become a member of SQL Maestros on YouTube, where you can pay a monthly fee, get access to all the paid webinars and advanced content. So in summary, you can go to SQLmaestros.com and become a member, or you can become a member on YouTube also. Becoming a member on SQLmaestros.com turns out to be a little cost effective with the annual membership in comparison to YouTube monthly membership. But anyway, choice is yours, whichever platform you wish to use. Happy SQL.